Hello everyone, welcome to Maths with Mr. JM. Today I'm going to show you how to solve this exponential equation. It reads 2 raised to the power of 9 raised to the power of x all over 8 raised to the power of 3 raised to the power of x equal to 1 over 4. Solution: 2 raised to the power of 9 raised to the power of x all over 8 raised to the power of 3 raised to the power of x equal to 1 over 4. We can write this as 2 raised to the power of 9 raised to the power of x all over 8 raised to the power of 3 raised to the power of x equal to 4 raised to the power of minus 1. Because in law of indices, whenever we have 1 over n can be written as n raised to the power of minus 1, which we have applied here. We continue. We can express everything in base 2. That is to say, 2 raised to the power of 9 raised to the power of x all over 2 raised to the power of 3 or raised to the power of 3 raised to the power of x equal to 2 raised to the power of 2 or raised to the power of minus 1. We continue. We can write this to be 2 raised to the power of 9 raised to the power of x all over 2 raised to the power of 3. We have power 1 here. 1 times 3 raised to the power of x equal to 2 raised to the power of minus 2. Because in law of indices, whenever we have a raised to the power of m into n is equal to a raised to the power of m n, which we have applied here. Then everything is in base 2. In law of indices, whenever we have a raised to the power of m times a raised to the power of n is equal to a raised to the power of m plus n. Now we apply it here. If we do that, we are going to have 2 raised to the power of 9 raised to the power of x all over 2 raised to the power of 3 raised to the power of 1, because we are adding the powers, plus x equal to 2 raised to the power of minus 2. Then we move further. In law of indices, whenever we have a raised to the power of m all over a raised to the power of n is the same thing as a raised to the power of m minus n. If we apply this here, we will have 2 raised to the power of 9 raised to the power of x minus 3 raised to the power of 1 plus x equal to 2 raised to the power of minus 2. Now we compare both sides. If we compare both sides, base 2 we cancel base 2, left with 9 raised to the power of x minus 3 raised to the power of 1 plus x equal to minus 2. Next step, we can express 9 in base 3, which is the same thing as 3 raised to the power of 2 all raised to the power of x minus 3. In law of indices, if we apply this law of indices, this will change back to 3 raised to the power of 1 times 3 raised to the power of x equal to minus 2. We can rewrite this first one as 3 raised to the power of x all squared is just by interchanging the power. Minus 3 times, we can denote by brackets 3 raised to the power of x equal to minus 2. Now we say let 3 raised to the power of x equal to n. Whenever we see 3 raised to the power of x, we put n. This will be n squared minus 3n equal to minus 2. Now this will be n squared minus 3n. We move minus 2 to the other side of equality, which will give us plus 2 equal to 0. This is quadratic equation. Now we have quadratic equation. We have different method of solving quadratic equation. We can use formula, which is quadratic equation formula. We can use factorization method. We can use completing the square. But in this case, we are going to use factorization method. Using factorization method, we have n squared minus 3n plus 2 equal to 0. All we do here, we multiply n squared times 2, which gives us 2n squared. We look for two numbers that we multiply to give us 2n squared. And when we add these two numbers, it will give us minus 3n. We write minus 3n. What is that two number? When we add it, it will give us minus 3n. We have minus 2 n and minus n. Minus 2 n and minus n. Next step, we have to write n squared. Instead of minus 3n, we replace it by the factor minus 2n and minus n. So we are having minus 2n minus n plus 2 equal to 0. Then we continue. We have n squared minus 2n. We put it in brackets minus n minus 2. We put it in bracket because if we have minus times n, we get back minus n. Minus times minus, we get back plus 2. So we continue. What is the factor in this bracket? What is common is n into n minus 2. When we multiply back, n times n will give us n squared. N times minus 2 will give us minus 2n. Minus the factor of this bracket is 1 into n minus 2 equal to 0. Equal to 0. Then, if we look at this bracket, the two brackets are equal. We pick one and we pick what is outside the bracket. What is outside the bracket is n minus 1 into n minus 2 equal to 0. For this expression to be 0, either one of the brackets will turn to 0. When it multiplies the other bracket, it will give us 0. Either n minus 1 equals 0 or n minus 2 equals 0. If we continue, n equal to minus 1 crosses sign of equality becomes 1, or n equal to minus 2 crosses sign of equality, it becomes 2. Therefore, n equal to 1, 2. So this is the solution to the quadratic equation. But that is not the end. Now we go back to this point where we have 3 raised to the power of x equal to n. Then we write here, recall 3 raised to the power of x equal to n. First case, put n equal to 1. Then we are having 3 raised to the power of x. Whenever we see n, we put 1 equal to 1. And in law of indices, whenever we have n raised to the power of 0 is equal to 1. So we have to express the right hand side to look the same base with 3. So we are having 3 raised to the power of x equal to 3 raised to the power of 0. We compare both sides. If we compare both sides, base will cancel base, left with x equal to 0. This is one of the solution. Then we move further. We write case 2 or second case. Three raised to the power of x equal to n. Put n equal to 2. We are using 2 this time. We have 3 raised to the power of x equal to 2. We compare both sides, they are not of the same base. We have to introduce logarithm. Now, log of 3 raised to the power of x is equal to log of 2. In law of logarithm, whenever we have log p raised to the power of m is the same thing as m log p. What is there? The power we times the log. So if that be, we are going to apply it to the left hand side. The left hand side becomes x log 3 equals to log 2. Next step, since we are looking for x, we divide by the coefficient of x, and the coefficient of x is log 3. That is x log 3 all over log 3 equals to log 2 all over log 3. Log 3 we cancel log 3, left with x. Then everything will becomes x equals to log 2 all over log 3, which is in base 10. Then we can rewrite this to be x equals to log 2 in base 3, which is the final answer. Therefore, x is equal to 0, comma, log of 2 in base 3 as the final answer. If this helped, please subscribe, like, and share. Thank you.